Redox reaction. Objective: we will learn about redox reactions and their types. You must have noticed the rusting of iron nails, burning of a magnesium ribbon with a bright white light, or even a cut apple turning brown. These are all examples of redox reactions. In order to study redox reaction, we must know what is oxidation and reduction. Oxidation is the process in which an atom loses electron and is converted into more electropositive or less electronegative state. Here, the atom which loses electrons is said to be oxidized, while reduction is the process in which an atom gains electron and is thus converted into less electropositive or more electronegative state. The atom which gains electrons is said to be reduced. The reaction, which involves both oxidation and reduction simultaneously, is called a redox reaction. Consider burning of magnesium ribbon in air. Here, 1 mole of oxygen combined with 2 moles of magnesium to give 2 moles of magnesium oxide. Let us understand this reaction in terms of oxidation and reduction. Each magnesium atom loses 2 electrons to form magnesium 2+ ion. Since magnesium loses electrons, it is said to have undergone oxidation. This half reaction, which represents oxidation, is called oxidation half reaction. On the other hand, oxygen atom gains 2 electrons to form an oxide ion. Oxygen is said to have undergone reduction. This half reaction, which shows reduction, is called reduction half reaction. Oppositely charged ions attract each other, forming 2 moles of magnesium oxide. The net reaction is obtained by adding 2 half reactions. 2 Mg plus O2 gives 2 MgO. We have thus seen how oxidation and reduction take place simultaneously in a redox reaction. Redox reactions are of 2 types. Direct redox reaction. The reactions in which oxidation and reduction take place in the same vessel are termed as direct redox reactions. A direct redox reaction takes place when a copper rod is dipped in an aqueous solution of silver nitrate, which is present as Ag+ and nitrate- ions. After some time, it is seen that the copper rod reduces in size and the solution turns bluish, while shiny metallic silver deposits at the bottom of the vessel. In this experiment, copper atom from the rod loses 2 electrons and gets oxidized to copper 2+ ion. Silver+ ion gains these electrons and gets reduced to metallic silver. This gets deposited at the bottom of the vessel. Thus, a redox reaction takes place in the same beaker. If a thermometer is introduced in the vessel, it shows a rise in temperature as the chemical energy is being converted to heat energy. Indirect redox reaction. The reactions in which oxidation and reduction take place in different vessels are termed as indirect redox reactions. Electrochemical cells are based on these types of reactions. For example, in an electrochemical cell, a zinc rod is dipped in zinc sulfate solution and a copper rod is dipped in copper sulfate solution. The zinc and copper rods are connected by a copper wire, and the 2 solutions are connected by a salt bridge. Here, zinc from zinc rod loses 2 electrons, forming Zn2+ ion. This is oxidation half reaction. Electrons, after traveling through the external circuit, reach the copper rod. At the copper rod, copper ions from copper sulfate solution accept the electrons and undergo reduction. Thus, redox reaction generates flow of electrons and electrical energy is produced, which can be used. This is the advantage of indirect redox reaction over direct redox reaction, where the heat energy generated is not sufficient enough to be used. Summary: We have learned that oxidation is the loss of electrons while reduction is gain of electrons. Redox reaction is a combination of oxidation and reduction. Direct redox reaction takes place in the same vessel with a rise in temperature, while indirect redox reaction takes place in two different vessels. Electrochemical cells are based on indirect redox reaction, which converts chemical energy into electrical energy.